Okay, we are still in section 6.1 talking about random variables. We're going to pick up where we left off in the last video. We were talking yesterday about discrete random variables and then continuous random variables. If you remember, discrete random variables, those take on a fixed set of values where there's no gaps in between. And so today we're going to be discussing how to find the mean and standard deviation of a discrete random variable. Okay, typically you're presented the information in the form of a probability distribution where you're given each possible value of the discrete random variable, and then underneath it its associated probability. Remember, to satisfy the two requirements for probabilities is each separate probability has to be a value between 0 and 1, and when you sum up all of the probabilities within a probability distribution, it must sum to 1. Okay, so we're going to take a look at an example that's kind of from Vegas here, a roulette example. It says, in the game of roulette, there are 38 equally likely outcomes on a roulette wheel. Each outcome is colored and numbered. So there are only 2 green sections, okay, 2 green outcomes. There are 18 red outcomes, and then there are 18 black outcomes. Okay, now here's how roulette works. If you bet $1 on red and the marble lands on either black or green, you have lost your dollar. If you win, then you get your dollar back and you win an extra dollar. Okay? So it says here, if you were to record the color that the marble lands on, are the outcomes considered a discrete random variable or a continuous random variable? Okay, we would respond to that neither. Okay, remember, to be a random variable, the outcome has to be numerical, and so if we are only reporting the color, we're going to say that would neither be discrete nor continuous because the outcome must be numerical. Okay, it has to be numerical. It cannot be a category like a color. Okay, so we're going to let X represent the net gain of one game of roulette when you bet on red. Okay, so when we talk about net gain, we're referring to how much money are you either ahead or how much money are you in the hole from having played one game of roulette betting on red. Okay, so the question first of all is this a discrete random variable or a continuous random variable? Okay, this would definitely be categorized as discrete, and that basically is because your options are, if you're playing just one game, you will either win $1 or you will have lost the $1 that you bet. Okay, those are really the only 2 outcomes here from having played a single game of roulette. All right, in part C here, it says find the probability distribution for X. Remember, we defined X to be the net gain of one game of roulette when you bet on red. Okay, so we're going to go ahead and construct, we had established in part C that there really were only 2 possible outcomes from playing one game of roulette. We're going to I'm just going to label our first row as X sub I, meaning this will hold what the options are for our net gain, and then the second row is P sub I, the probability for that. Okay, so our options are you're either up $1 or you're in the hole $1 from having lost the dollar that you bet. Okay, if we go back up and we look at the directions of how this is describing a game of roulette, it says there are 38 equally likely outcomes on the roulette wheel. Now remember, we're defining a random variable as having bet on red. Okay, so you would win $1 if it landed on red, and there are 18 red outcomes. So the likelihood of you gaining $1, whoops, let me fix that here. All right, likelihood of gaining $1 is you have 18 out of 38 chances of gaining $1. That leaves you with, there are 18 black outcomes, but also these other 2 green outcomes, so there are 20 out of 38 chances that you would lose and therefore lose the dollar that you bet. Okay, and so what we're going to try to explore here is how could we calculate a player's average gain. Okay, so if we're talking about, having played the game of roulette repeatedly over and over and over again, what would be considered a player's average gain? Some games you'll lose, some games you'll win. So on the average, are you generally in the hole, or are you generally, and by how much? So let's take a look on the next page at this notion of finding the mean of a discrete random variable. And you'll see the phrase expected value used quite a bit. That can just be used interchangeably for wanting to know what the mean of your discrete random variable is. Okay? So when we talk about calculating the mean of a random variable, it means that we're referring to a long run average outcome for that random variable, not just having played a few games, but that you're going to look at this repeatedly over and over and over again, a long run average. Okay, so if we were to run this many times, it's the outcome that you would expect to see on average. Okay, now this is very important. When we calculate the means or the expected values of discrete random variables, the answers don't have to actually be one of the possible outcomes, okay? It can be something in between. So it's very important that we are not rounding our answer. And you'll see this demonstrated when we take a look at this example here. But you see in this green box, what's presented for you here is essentially the formula for how to calculate the mean or expected value of a random variable. And so what we're looking at here is the first row is just whatever the individual values would be for that random variable, and underneath their respective probabilities. Okay, the good news is the formula for how to calculate the mean of a random variable, that formula is actually on the formula sheet. Okay, it looks like this. Okay, and it's denoted, I believe, with a mu sub x. Okay, also it can be denoted as a capital E of capital X, like that. Okay. Now, if we were to break down the formula, we see that sigma symbol. We know that's a summation symbol. Okay, that kind of creates this loop where we're going through and we're taking each value of the random variable and we're multiplying it times its respective probability. Okay, so we multiply here. Okay, and then we're going to add that product to the product of the next value of the random variable times its probability, etc. And we just kind of follow that pattern all the way through. And when we sum up those products, we are left with, on average, what the expected value would be in the long run for that discrete random variable. Okay, so we're asked here in this example to both find and then interpret the expected value for this roulette example that we had just discussed here. Okay, it's asking us to perform the calculations by hand and with a calculator. Okay, note though, it is very crucial, you are always expected to show some work when you're doing your calculations on the AP exam. So I have over here, here's kind of our formula here for expected value. If we're looking for, what are we looking in the long run? Are you going to be ahead? Are you going to be in the hole, and by how much? Okay, if we were to flip back to the previous page where we had already constructed the probability distribution, here's where we're going to take the dollar times its probability 18/38 plus the -1 times its probability 20/38. And this certainly was a very small probability distribution, so it wasn't a big deal in terms of needing to show the work for this. We'll talk through how do you do this if your probability distribution is extremely long and you have a lot of values to show. Okay, there are things that can be done to kind of save a little bit of time. But when you multiply these together and then add their products, the value you end up getting is the number -0.05. Okay, -0.05. Okay, so what we're essentially saying is we're going to label that as dollars. So you're in the hole a nickel on average every game you play. Okay, and they did ask us to interpret this, so we can kind of write this out in a little better way here. Okay, it's really important when you are interpreting an expected value or the mean of a random, discrete random variable, that you are referencing that this is only true if you have repeated this event many, many times. So we want to start out by saying, after playing many, many games of roulette, okay, on average, the net gain is actually a loss of 5 cents per game. Okay, and you generally find that a lot in Vegas anyhow. Usually the odds are in favor of the house. They set things up in such a way that they are designed to always come out on top in the long run there. Okay, so that would be the interpretation for the mean for that. Okay, so let's take a look at how to find the standard deviation, which actually comes from the variance for a discrete random variable, and we can sort of talk about what that would look like in the context of this problem as well. Okay, so the standard deviation of a random variable x, that is measuring how much the values of your variable typically vary from the mean. Okay, now that idea shouldn't be anything that's foreign. We've been talking about standard deviation for quite some time, and that is really what standard deviation tells us. How much a value, if you were to choose at random, how much that typically would vary from where the mean is located. Okay, so you can see here, again, in this green box, we have a probability distribution here. Okay, and you'll notice that the formula is first expressed as the variance of the random variable. We know how standard deviation relates to the variance is the standard deviation is merely the square root of the variance. And so we're going to calculate the variance first, and then to get the standard deviation, we would simply just take the square root of the variance. Okay, so I'm just going to kind of circle that just to make sure that we keep in mind that that is just simply the square root of the variance. Okay, again, the good news here is this formula for the standard deviation of a discrete random variable, it is located on the formula sheet, but again, as most of these formulas typically work, you have to make sure that you're understanding what these variables are representing so that you can actually use the formula. So let's take a look at, I'm going to back up here to this variance formula. Okay, it looks like the way this is working is you're to take the first value of your random variable. You would subtract the mean from it. After all, that's what we're looking for, is how much these values typically vary from the mean. So you're going to subtract the mean. You would square that difference and then multiply that squared difference times its respective probability. And that is the pattern that you repeat for each value. Subtract the mean from it, square the difference, multiply times the probability. Those get summed up, and then you would take the square root of that. So again, this symbol mu sub x right there, that is representing the mean of the random, discrete random variable. Okay, so in the previous problem, we had calculated the mean of the discrete random variable. You would have to do that first before you calculate the variance, because you need that value in the formula. You can see that right here in each of these places in the formula. Okay. Now, this formula is pretty lengthy. Okay, we're going to take a look at how to use it, but there is a little bit of a shortcut here. There's still some work that we will have to show, but on the next page, I'm walking you through how to do a couple of things. One, how to make a histogram of your probability distribution on the calculator. I had alluded to this in the previous video with the APGAR scores. I think that's what we're looking at here in this example. If you were going to make that probability distribution that they had a few pages earlier here on the notes page on the calculator, you would input the actual random variables in L1, you would put their respective probabilities in L2. You can see that demonstrated right here in this graphic. Okay, but here is the crucial part. When you go to set up your histogram, okay, when you're going to graph your histogram, it's very important that underneath or across from the frequency label that you are putting L2, because after all, what you did put in L2 was essentially the frequency of each of those values. That's the likelihood or probability of that occurring, okay? So you would put an L2 label next to frequency, and that would construct your probability distribution histogram, okay? What we're going to focus on here, you'll look at step 3, it mentions how do you calculate the mean and the standard deviation on the calculator, okay? Once again, there is still some steps you would have to show on your paper, which we'll talk through, but you find this by, you would definitely put the same thing up above. Your values of your discrete random variable go in L1. You would put the frequencies, the probabilities in L2. You would then choose that one variable statistics feature, okay? That's underneath the stat button. And you bump over to the calculate menu and you choose option number 1 labeled 1 variable stats. That's what we've done multiple times when we have wanted to calculate a mean, standard deviation, 5-number summary for a box plot. All those values are there. It pulls up a screen though that looks like this. It says 1 variable stats, okay, across from list. We typically put L1, and here's the part that you'll need to make sure that you have. Where it says frequency list, we had always left that blank before, okay? If your probabilities are in L2, you need to definitely make sure that you are putting those probabilities, that you're designating that that is in L2. Then you will go down to the calculate menu. It'll spit out a lot of those values. Something definitely that is worth noting, though, is you'll notice that it doesn't actually give you a sample standard deviation value. I made a little note over here off to the side sort of explaining why that was. You're going to need to grab this sigma value. That's the population standard deviation, okay? And that's what we're using for the standard deviation for the random variable, okay? So you could run this, and you could pull both the mean of your random variable from the X bar, and you could pull the standard deviation for your random variable right down there across from the sigma. Okay, so let's look at this APGAR score example. Okay, on the next page here, and this is going to be the last page that we're going to wrap up here for this video. Okay. What you would need to do, and this would be good practice if you were to pause the video and go ahead and do this, is place these APGAR score values in L1 on your calculator, and then in L2 type in those probabilities. So if you want to pause the video and go ahead and do that so that you can kind of run through this process on your calculator, I think you'll find that valuable. Okay, you'll notice here that I went ahead and listed, here's our formula for how to get what the average or expected APGAR score would be for a randomly selected baby. Okay, that is on the formula sheet. Okay, and then here's the formula for the standard deviation of a discrete random variable. Okay, now I did mention here again, you always have to show work when you're doing calculations on the AP exam. Okay, so here's what we would do. I don't know, there is this is a much larger probability distribution than the roulette example that we looked at, because there's a lot more options for our discrete random variable. So when it asks us to compute the mean, okay, and we can label this mu sub x, we could label it capital E of capital X, either way is fine. You need to show the first probably 2 or 3 parts to the formula. Okay, now remember how this works. This is saying you take each value of your discrete random variable and you multiply it times its probability. So we want to show, we're taking an APGAR score of 0 times its probability of 0.001. You can kind of see here, I'm going to go through about the first 3 of these so that the grader on the AP test can see that I have an understanding of how the formula is working. After I've done about 3 of them, I'm going to put a plus, and then I'm going to put an ellipsis symbol, just kind of the 3 dots, alluding to the fact that I would continue on with that same pattern all the way to the APGAR score at the end of 10 times its probability. But then if you wanted to, on your calculator, run the one variable stats, okay, but you have to be very careful, and again, make sure that across from where it says frequency list, you are placing an L2 in that location, okay? Okay, you can run it. What you're going to pull then for your mean is you'll be pulling what's across from the X bar, and that should be roughly 8.128. Now, if you remember on an earlier page, I had mentioned that when we're saying what the average or the expected value is, you should never round that, despite the fact that it's not possible for a baby to have an APGAR score of 8.128. That is what you should cite as being the average, okay? So this did ask us, I believe, to interpret this, okay? So we're going to interpret this as being the long-term average APGAR score. Okay, you need to make sure that you are including this terminology at the beginning rather than just saying the average APGAR score is 8.128. Okay, we need to make sure that we're referencing the fact that this would be like looking at many, many newborn babies. So the long-term average APGAR score of many babies is approximately 8.128. Okay, and I'm just going to make this note that we should never round this expected value. Okay, don't round that to 8. Okay, so if we were to kind of do the same thing here for coming up with what the standard deviation would be for the random variable and interpreting that in context, okay, I'm going to go ahead and put my symbol here for standard deviation. Okay, I'm going to do the first 3 kind of cycles through the formula. So that would be taking the APGAR score minus the mean of 8.128 that we just calculated. We're going to square that, multiply it times its probability. Okay. Then we move to the next one, subtract the mean, square it, multiply times its probability. So I'm going to go through the first 3 cycles here, writing this down so it's very clear to the grader. I'm going to put plus ... Now, this is not the variance, this is the standard deviation. So when I get that written, I need to put a square root symbol over top of all of that. Okay, otherwise, that would be representing the variance. But then I'm really going to just pull this value from having run one variable stat on the calculator like we did up in part A. Okay, again, if I just flip back to this previous screen, that value is going to be labeled as that sigma x there. Okay, then we're going to interpret this. So the interpretation would be, on average, a randomly selected baby's APGAR score will vary, very important word there, will vary from the mean, I'm just going to cite the mean here in parentheses, 8.128, by about 1.437, okay, 1.437. Okay, and let's go ahead and just wrap this up with one final example. This one is a much smaller probability distribution. Here we're revisiting that example that's talking about our random variable being the number of languages that a randomly selected U.S. high school student could speak. Okay, they're asking us to find and interpret the expected value. That would be the average here. Okay, so I'm going to show just the first few. Now, this isn't a really big probability distribution, so you could do this one by hand if you wanted. Okay, but since this is asking for both the standard deviation and it's asking for the mean, you may just want to put the data into L1 and L2. Okay. All right, we showed the first few cycles, so I'm going to go ahead and jot down here. The mean is 1.457. I would be pulling that from the X bar screen after I ran one variable stats. Okay, I'm going to interpret this. I'm going to say the long-term average number of languages spoken by a randomly selected U.S. high school student is approximately 1.457. Okay. Once again, even though you can't necessarily speak I guess you can speak part of a language and not know it fluently, but this should never be rounded. Okay. Always make sure that you carry that out to the exact value. Okay. And then for standard deviation, we're going to show the first few cycles. That's going to be one language minus the mean that we just calculated squared times the probability. Okay. Just going to do this for the first 3 cycles through this here. Then I'm going to put ... It's going to be the square root of all that. Very important that you're putting the square root over that. Okay, and then I'm pulling this value from the screen, so it's going to be 0.6709, and then my interpretation is simply going to be, on average, a randomly selected U.S. high school student's languages spoken would vary from the mean, I'm going to put that in parentheses,